Good morning. We're going to go on to our next section. Again, I'm a little bit low on time, so I'm going to be going nice and fast. Looks like my video is a little bit laggy right now, and I'm not sure why. So hopefully that won't bother you too much. Okay, so we're going to do section 3.4 today, and we're going to be, hopefully this is a review, but it sounds like it may not be for some. So you may need to watch it slow or rewatch some of the examples. We're going to be talking about adding fractions. Date is 10/18. Alright, so when we're adding fractions, first let's remember that we have our numerator and we have our denominator, denominator, and up here it represents the number of pieces. Man, I can never spell that word right. I think I was right the first time. And this is the size. I'll just call them slices so that I can spell them better. And we have some rules when we're adding fractions. If I was going to add something like 1 plus 1, we would all know that that ends up into be 2. Because if I look at them as fractions, this is one whole, and if each size is a whole, right? Plus one piece of a whole is equal to 2 pieces of a whole. So 2 wholes. One whole plus one whole equals 2 wholes, right? So we need to do the same thing when we're doing fractions. We have a couple of key rules. We need to write them as equivalent fractions so that the denominators, or we're going to use equivalent fractions to make the denominators the same. Okay, so if I want to add 1/2 plus 3/2, that's easy for me to do because all I need to do is add the numerators. 1 plus 3 is 4. And if my denominators are the same, and they are here, they stay. They don't get added, they don't change. Because this is like if I have 1/2 plus 3/2, I add them all together and I end up with 1, 2, 3, 4/2. Easy enough. And this is how we represent it mathematically. The problem starts to happen when we have things with different denominators and we have to try to add them together. Let me show you what we do. Let's write down our couple of steps to do this. Our first step is we're going to rewrite the fractions using equivalent fractions so the denominators are the same. Let's take an example. So if I was going to add 1/2 plus 1/3, I can't do that. So first I would have to use my equivalent fractions to do that. I need to find a common denominator, a number that 2 and 3 both fit in. And I can see that 6 is going to work. So I need to turn this 2 into a 6. So I'm going to multiply this 2 by 3. And that's going to give me, to do the same thing on both sides. So that's going to give me 3/6. And I have over here, I need to turn this 3 into a 2, this 3 into a 6. So I'm going to multiply it by 2 as well as the top. And it's going to give me 2/6. And now I can add them. My second part, my step number 2, is add the numerators. And keep denominators the same. So if I was going to use my example again, I would say 3 plus 2 is 5. My denominators stay the same. Now sometimes, then I'm going to have to simplify. Can you guys see that? Oh, not really. is my final step. And that, remember, I look and see if there's a number that I can fit into both that I can kind of reduce it by. This one is not. This one is simplified already. So we are good to go. Okay? Let's take a look at some examples. Example 1. We are going to add, let me just get close enough to see, 3/4 plus 2 3/5. Alright, so just like before, I am going to ignore this kind of whole number out in the front. And I'm not going to be using it for now. Not necessary. I'm going to save it for later. So I need to add 3/4 and 3/5. Alright, now I got to find a common denominator, a number that 4 and 5 will both go into. And if I wanted, I can start writing them out. I can say, okay, I have 4, 8, 12, 16, 20, 24, 28. These are all kind of if I count by 4s. If I count by 5s, I go 5, 10, 15, 20, 25. Okay, so I do notice that 20 is on both of these lists. So that's really nice that I can tell that it is a common denominator that I can use. So I'm going to turn both of the bottom of these fractions into 20ths. Okay, so to turn a 4 into a 20th, I have to multiply it by 5, and I have to do the same thing I did to the top that I did to the bottom. So this is going to turn this into 15 20ths. Okay, to turn this 5 into a 20, I'm going to multiply it by 4. And if I do the 4 on the bottom, I have to do the same on the top. So I get 12 20ths. So now I really have, I can bring this one down. I've got 15 20ths plus 12 20ths plus my original 2, because I don't want to forget about it. Okay, 15 and 12, what is that? That is 27 20ths. So I can put my 2 and 27 20ths. Now, we need to remember that final step. Our final step is simplify. 27 20ths is an improper fraction. We call it that because there's more pieces than there are sizes. So I can take 20 of these away from that fraction and turn it into 7 20ths plus 1, because I have a whole that I just kind of took out. And that 1 gets added back in, so my answer is going to be 3 7 20ths. Kind of makes sense? Let's do another example. Now, I took a lot of space on this one, so I'm going to use another page. You don't have to if you're more of a compact writer than I am, and I suspect that many of you are, which is totally fine. All right, let's take another example. We are going to look at adding 9 1/2 plus 22 1/4. Alright, so I need to make these fractions common denominators. Now this one kind of screams out to me. I have 4 and I have a 2, so I can just turn this 2 into a 4. So to do that, I'm going to take my 1/2 and turn the bottom into a 4. I'm going to multiply it by 2. And then I have to do the same thing to the top. So I end up with 2/4. So I can rewrite this whole fraction, or this whole problem like this. 9 2/4 plus 22 1/4. Okay, then if we remember our second step on here, now that I've got common denominators, add the numerators and keep the denominators the same. Okay, 2 and 1 is 3, and I'm going to keep my 4s the same. So I have 9 plus 22, which is 31, plus 2/4 and 1/4 is 3/4. And that is simplified because I can't get it any lower than that. Okay? Nice. Let's try another one. Example 3. I'm going to add, 5 1/3 plus 1/7. Ooh, I forgot to draw a box around my answer. Darn, I do forget that sometimes. Move this up a little bit. All right, so my 3 and my 7, I'm going to have to find a common denominator. Now, as a mathematician, I can always cheat if they're kind of lowish. It helps. I can just multiply them by each other, and it'll work. So I'm going to take 3 times 7 times 7. And I'm going to take both of these sides by 3. And that's going to give me 7, 14, 21 on the bottom of both. Because 7 times 3 is the same as 3 times 7. 1 times 7 is 7. 1 times 3 is 3. So now I have 5 plus 7 21st plus 3 21st. So I have 5 and 7. I need to remember, add the numerators, keep denominators the same. 10 21st. Now, is there a number that I can fit into both of these to simplify it? Well, no, because the only one that fits into 21 is 1, 21, and 7. And in 10, we have, what, 1, 2, 5, and 10. And they don't share factors. So this is simplified. Okay, I want to do one more quick example, okay? This one, we're going to be comparing, we're going to add up some fabric. And we're going to be adding, I'm going to go fast in this one because I'm low on time. 6.5 plus 3 2/3 plus 5 4/5. Alright, so the problem this time is that I need to get something that all of these will become common denominators with. So I can pull out my whole numbers if I want. I can do that later. So 6 and 9 and 5 is 14. So I have 14 plus, and I can do that, remember, because of my commutative and associative. As long as I'm only adding, it works. So I have 1/2 plus 2/3 plus 4/5. And I made space in there because I'm going to be doing some equivalent fraction work. Alright, what can I fit into everything? Okay, does 10 work? Well, 10 works for 5 and 2, but not 3. What about 15? Oh, 15 doesn't work for 2 because it's not even. That makes me think I'm going to be going to 30, because 30 is going to be able to fit all of these things in. So I'm probably going to need to go to 30. So to get 2 to 30, I'm going to multiply it by 15. To get 3 to 30, I'm going to multiply it by 10. And to get 5 to 30, I'm going to multiply it by 6, right? Yeah. Okay, let's write these out. We have 15 30ths, I have 20 30ths, and I have 30ths, and I have 24 30ths. Okay, so now I have to add just the top. 15 and 20 is 35. 35 and 24, is 9, 5. 59. I have 59 30ths. Okay, this should again scream out to you. This is an improper fraction, so it's not going to work. So I need to pull out a whole, which means I can pull out 30 from 59. And 59 minus 30 is going to give me... Oops, I didn't have to do that. That was dumb. Let me rewrite that. 59 minus 30 is 29, right? So I can write this again as 1 and 29 30ths. But I can't forget my little 14 that I put earlier. So I have 14 plus 1 and 29 30ths, which gives me my answer. Sorry, I made a big mess of this problem. Is 15 and 29 30ths. And that's kind of how I would figure this one out. Now, when you do yours, you might be able to find a little bit of a cleaner way to do it, but it's the steps that are key, and that's what I really want you to notice. All right, I'm going to be signing off, and good luck on our adding fractions.